Okay, this is another one of those slightly irritating situations where I've kind of done the whole thing and then the video hasn't saved properly. So this, using a different past paper, this is what the question looks like originally. Okay, so I'll kind of skip between the two. So when I did this in the first video, I really stressed the fact that because this is 5 marks, even if you look at this and you think it's really difficult, you need to at least look at, right, which bits of this are bits where I might be able to pick up a mark or a second mark, and then from there something might happen where something will click and you'll be able to get through to the final answer. But how can I pick up my first few marks from this? Well, firstly, it mentions that this is a regular pentagon. So a bit like earlier on in question 4 when we were doing interior and exterior angles, when I first did this I was talking about how you could work out what this angle is here by realising that it's the exterior angle of a pentagon. So if I do 360 divided by 5, so all the exterior angles of any shape are 360, so because it's a pentagon with 5 sides, if I divide that by 5, I've shown that of this regular pentagon, I've shown the 1, 2, 3, 4, and then this one 5 exterior angles of a shape. So each one of these where I'm putting my pen will be 72 degrees because these 5 exterior angles add up to 360. So this calculation lets me know that this is 72. If you remember this pattern that every time you add a side, the angles inside a shape go up by 180 degrees, I can also think about these 5 interior angles, and I can do, right, 540, which is the angle sum inside a pentagon, divided by 5, mean each of these inside angles here will be 108 in total. So all of these, once you know that's 108, you could then say, right, angles on a straight line, 180 minus 108 gives you 72 degrees down here. Now I'll just say this verbally like I did the first time, but just to be safe, it's worthwhile writing in, especially if you have time, your reasons behind doing each of these. So this one, exterior angles of any shape add up to 360 as a reason. This one, the interior angles of a pentagon add up to 540. When you work out 72, if you've done it this way, angles on a straight line add up to 180. But yeah, if that's a regular pentagon, as soon as you see that, I'd be thinking marks by working out the interior and the exterior angles. The reason I've focused on this exterior angle is because further on it says, the whole point of this question, prove that ST, which is this side, equals UT, which is this side. So I've drawn these lines on to show what we're trying to show, that they're the same. Now, we're not given any side lengths on this question. So as soon as I'm told to prove that these are the same, without any side lengths, we're relying on the fact that you recognise that if these two are the same, this must be an isosceles triangle. So what about if we prove that these two angles are the same, and then that's proof that we have an isosceles triangle, and that's enough for us to say that these two sides will be the same. So because there are no side lengths, we're going to focus on showing that these two angles are the same, showing that it's isosceles, and that is proof that these two sides are the same length, ST and UT. Now this 72 we've already worked out with the regular pentagon stuff. This comes a little bit later on in my working. So in the previous video my next step was to read through what are the other clues to how we can pick up further marks. R, U and T are points on a circle. You can see that clearly, they lie on the circumference. That's not that useful. QR and PT are tangents to the circle. Now hold on, if QR is a tangent and PT is a tangent, there must be a reason why this circle is here. There must be circle theorems involved. And one of the circle theorems is that where a tangent meets a radius, and this was the clue as to drawing in these extra lines, because where a radius meets a tangent is always 90 degrees. Where a radius, so I drew this line in, meets a tangent, you're told that PT is a tangent, is always 90 degrees. Now, as well as getting a mark for working out the interior, exterior angle stuff, you get a mark just for showing or stating that these are 90 degrees for using that circle theorem. Now, I've created another pentagon, so these these angles inside here must add up to 540 degrees. If I know that these two are 90 and these two are 108, that is how I then went on to calculate that this is 144. I said that if this is a pentagon, the total angle sum must be 540. So by subtracting the 4 that I already know, so the 90, the 90, the 108 and the 108, I got this middle angle to be 144. And then using another circle theorem, an angle subtended from 2 points at a centre is always twice as big as an angle subtended from the same 2 points at the circumference. So from R and T, I'm creating this angle at the centre, and I'm also creating this angle on the circumference. So if that's 144, I've just halved that to say that this angle must be 72. And from there, if these two angles are the same, if they're 72, then we can say that ST must equal UT, this side must equal that side, because the two angles at the bottom are equal. That's basically what I've written, which makes it an isosceles triangle. So anything along those lines. Bits that are missing, I could have given more written reasons for each of my steps. You should try and write those in, especially if you've got time in your exam. But yeah, that's basically a quick recap of what I did to answer this question.